Tonight, I'm delighted to introduce our guest lecturer, Dr Helmut Engelbrecht, who will be talking on the theme, Energy for All, How Can Nuclear Energy Contribute? As Chief Executive of URENCO, one of the world's biggest suppliers of enriched uranium to the civil nuclear power industry, Helmut has deep insight into the business of nuclear energy. You'll be aware that the whole subject of energy policy is very close to the Academy's heart, and much of our policy advice is in this area, the most recent being a review of Great Britain's energy capacity margin. We've been strong advocates of the importance of nuclear energy as part of a sustainable mix for low-carbon generation. Helmut's early career was with NWK in Hamburg, where he was manager of core reactor design. He then went on to specialize in fossil fuel purchasing while managing the nuclear fuel cycle, and was later appointed director of E.ON Benelux. Helmut joined URENCO in 2003 as strategic development director and was appointed Group Chief Executive Officer in 2005. He strongly believes that every person on the planet is entitled to the basic essentials of life, including affordable energy, and that affordable energy is key to progress for developing nations. And Helmut will argue and believes that the environmentally responsible way to provide this sustainable energy is through nuclear energy. And I'd now like to invite Dr. Helmut Engelbrecht to give this lecture, and after that he's agreed to take questions. Helmut.
Good evening, ladies and gentlemen. It's a great honor to be able to address you here tonight. This is addressed as a view from the top. I'm flattered. Thank you. But realistically, I'm afraid this will be just a review of 30 years' engagement in energy-related matters that I would like to share with you. It's an attempt to try to understand some of the developments that we have seen over the last decades and which, at least to an engineering mind, sometimes seem to defy logic. So please accept that this presentation is my personal view and definitely does not represent the opinion of the company I'm heading, URENCO. Dame Anne Dowling, thank you for introducing me in the kind way you did. But if you allow me, I would like to add some more details to my personal career, because it might help you to put some of the statements that you will hear later on into the right context. After school, I decided to train as an engineer. I studied mechanical engineering, majored in nuclear engineering, and did a PhD based on a nuclear physics topic. With that kind of background, I joined a utility that was operating at that point in time 3 reactors, and I was put in charge of core design. I honestly believed with my scientific education I would have a fair chance to actually move things. Well, I had to learn very rapidly that ultimately the only thing that matters was economics. So, in short, technically everything can be done, but if you can't pay for it, it won't succeed. Thanks to frequent changes in the organization, I took up quite a variety of jobs over time, responsibility for purchasing, for M&A, and then I ended up, as mentioned, being a director of a Dutch utility. That was the first time when I actually came in contact with the most important stakeholder of all enterprises, the customer. And that's where I really learned a lot. Now, in 2003, back at URENCO, back in nuclear industry, I really was puzzled to find the old question that I never had found a convincing answer for: why is nuclear energy not striving still up on the agenda and still unanswered. And honestly, to some extent, it's still today the same. So what I'm trying to do here tonight is see whether I could get somewhat closer to the answer why the industry is not booming as it should. The world needs energy. Power is key to any modern society. Not only technology, communication, but also basic human needs depend on the reliable supply of energy and power. Think of water, think of food. All predictions show that energy demand will double over the next 30 years. There are two drivers for that: the growth in global population, but maybe even more important, the catch-up that lots of the global population has to do in their standard of living in order to come to the same levels that we enjoy today. Providing that amount of energy, double of what we have today, simply by the traditional means, which is burning fossil fuel, becomes more and more unrealistic, and I believe that that is a growing recognition worldwide. Even if you do not believe on the man-made impacts of CO2 release, just watch the television news from Peking. See the smog there, how it hinders the city and the people, and how it causes damage to the health of the Peking and Chinese population. That should be evidence enough to anybody that we need to change things. So I strongly believe that the future supply of energy and its use should try to avoid and better, at least limit, its emissions. Ultimately, technical solutions to increase the comfort of living shouldn't be paid for by increasing the hazards to the environment. If you look at the solution, nuclear springs to mind. It fulfills all these requirements. Why is it not booming? Rather the opposite. Over the last decade, the nuclear share in global electricity production has reduced from 15 to 12%. Let's try to understand that. If you look at today's energy situation, at least in developed countries, in societies that have our standard of living, it's normally referred to as a trilemma. But let's keep in mind that the majority, or that a big part of the global population would be happy to have that trilemma. For them, security of supply is still the only matter subject. And if you ever had the experience of a power failure, you will know what it means to be without electricity. I remember being stuck in a supermarket. The power disappeared. You couldn't even pay, leave alone exit the shop. So it is really a burden. And if you come then, so security of supply is the key. Only if you have that, I think you will start thinking about affordability. And let's be honest, whereas an interruption of supply has an immediate effect, affordability is at best a long-term effect. If you have been used to a certain standard of living, a certain supply of energy, you will not change your energy usage pattern simply because the price changes a little. I've tested that idea earlier when we were downstairs. How many of you know what you actually pay for electricity? So for the private person, electricity prices do not really matter. This is totally different for industry, because industry, in its production cost, in its competitive situation, does notice when energy prices change to their disadvantage. And for your long-term investment decisions, for the consideration where you want to place your operation, energy predictions play a major role. So I'm not surprised when I read in the press that thanks to cheap shale gas, a lot of energy-intensive industries in the last 2-3 years have decided to invest in new facility in the US, because there is where they find the most favorable conditions. Emissions, environmental impact, is a long-term concern related to energy supply and energy usage. The evaluation of that impact is definitely global, but the reaction is more based on what the individual experiences, and unfortunately not always logic. If you need an example, look at my home country, Germany, where we actually phase out nuclear environmental clean, emission-free to replace the missing electricity quantities by burning lignite, which is about the fossil fuel with the highest CO2 emissions. On the other hand, we subsidize biofuels. This is mainly corn and has a major agricultural impacts that's harvested, turned into gas and burned for power. And quite honestly, I'm not convinced that that is contributing in any way to the overall reduction of energy-related emissions. But people are committed to that, people believe in that, and people are, for the time being, willing to pay for that. I think here we have a responsibility to actually get factual matters right and to avoid that the big public support that is given globally for increasing environmental conditions will not be ruined by some pressure groups arguing their case and ultimately not working to the overall aim. But back to the original question. Why is nuclear energy not succeeding in such a situation? And let me try a somewhat odd explanation. Now, the first thing I have to mention when you look at that graph, I'm not going to mention the brands of these cars because I don't want to get myself into some legal problems. I simply show you this picture to show you what I mean when I talk about a big and a small car. So, if you ask yourself which car you want to have, I think the instinctive reaction is obvious, the big one. Second thought, wait a minute, what do I need it for? So the choice ultimately depends on the customer's needs. If you want to impress your partner, it's the big one. If you want to get efficiently from A to B, it might be the small one. But what differentiates these two cars? One, the big one, is almost bespoke, almost handmade, and unfortunately quite expensive. The small one is a mass product, built several 100,000 times, sold to and used by a global customership everywhere, priced at a fraction of the big one. When it comes to luxury, the big one is the winner, the small one is no comparison. But interesting enough, if you look into the reliability to get from A and B, they hardly differ. So, the important thing to note in this comparison, I think, is that historically, only big cars were built. They all were bespoke, they all were handmade, and they all were very, very expensive. Only when they started to manufacture more, entered into mass production more or less, their utilization increased, their quality increased, and the prices came down, or linked to each other. And that was the foundation for the mobilization that we take for granted today. Now, what is the equivalent in nuclear industry? Today's reactors are built only a few times. They are bespoke to national regulations. Nuclear energy today, I'm afraid to say, has no equivalent to the small car. But more to that later. First, I would like to reflect why our industry chose to provide the energy needed with the big car solution. Nuclear technology for civil use was developed in the 15 and 60s, and initiated by Eisenhower's famous speech of Atoms for Peace. At that point in time, electricity markets worldwide were regulated markets, power consumptions grew, at least in the developing nations, in double-digit percentages, and accordingly, security of supply, as mentioned earlier, was the only feature that mattered. So, utilities invested massively because their only task was to provide electricity by all means, and in order to be able to supply the increasing demand, they bought the power station that was bigger because they simply couldn't build small power stations rapidly enough to feed the constantly increasing demand for electricity. That was the time when utilities also invested in security of supply by buying coal mines, all to ensure their continuous operations of their valuable investment. And just as an anecdote, that was at the time when utilities founded URENCO, all for security of supply. At the same time, in order not to risk the availability of their new power stations, unfortunately, the utility gave in easily to all the requests of the regulators. Even so, very well intended, individual regulation ultimately hindered international harmonization and standardization. And that's why today there is a lot of power stations worldwide, but none alike, not in a country and definitely not on global scale. Now, in order to have some cost reductions, they actually allowed the size of the power stations to become bigger and bigger. The development started somewhere at 50 megawatt, and today I think we are at 1600 megawatt. It was economy of size. The cost for all this was calculated into the electricity rates and paid by the consumer until the market changed. In the 1980s, it was triggered by a decline in growth rate for electricity demand. From 10% it went down to 2-3%. So accordingly, all of a sudden, affordability became a topic. Politicians worldwide thought about how to create some competition in the power markets and came up with deregulation. The UK went first, Europe followed, other developing countries worldwide followed. And what did it mean to nuclear industry? All of a sudden, you had different customers. There was no longer the big utility, but individual industries and consumers that all were asking for different things, that all were asking for solutions that they saw fit for their needs. The other consequence was that in such an environment, utilities could no longer rely on that their customers would pay by all means the investment they were just doing, unless they found somebody to subsidize that investment. So accordingly, the effect was that there was hardly any big investment in any big power station anymore, and the few investments that happened were only working out when there was subsidies that supported this kind of investment. Now, let's look into this slide and the global situation. This graph shows that overall, the nuclear capacity worldwide is predicted to grow. But what you see is that actually it's mainly growing in those countries that, first of all, have a regulated energy market, and second, still have growth rates for electricity demands in double-digit percentages. But if you see it's China, India, and the Middle East, you immediately ask yourself, and what about the other developing countries, South Africa, Indonesia, others, just for examples? Due to the development of nuclear technology in always bigger sizes over the last decades, due to economy of size, dictating ever-increasing size of generation units, nuclear reactors today require some sophistication to be used. You first of all have to be able to finance the investment, $5 billion per unit and upwards. Second, you need to have the infrastructure, or you have to build it, to be able to transmit and distribute the power you produce to the customers. And third, and not to be underestimated, you need the intellectual and educational capabilities to actually maintain an investment and operate an investment like that. One, several, all of these factors are missing in many countries around the world. Now here on this graph, Russia and Korea have all established this kind of background. They have still regulated markets, so it's quite likely that in those countries the energy provided by nuclear will grow. The United States is a very interesting market because it's not one electricity market, but there are several regions independently acting as an electricity market from each other. And some of them are regulated, some of them are deregulated. Now, fascinating, in deregulated market, cheap shale gas brings the electricity prices down so far that some of our customers there have decided to shut down their nuclear units because they cannot afford to operate them anymore. At the same time, in the regulated part of the country, some of our customers are building new reactors because they claim it's in the long-term interest of our customers that we do not rely on gas only. We need to diversify our sources for electricity production, and that's why we build nuclear. So the market conditions definitely have an influence. In Europe, well, most European markets are deregulated. Accordingly, expectation is that the overall share of nuclear will decline in Europe. The UK here might seem to be the exception to the trend. But allow me to remind you that without the incentive given by the British government via the contracts for difference, the specific investment in nuclear power in the UK most likely would not happen either, because no investor can take the financial risk without having some certainty on the prices he will achieve later. I would like to congratulate the British government, because with this contract of difference, they really have achieved something. They have matched the conditions of long-term infrastructure investments to the needs of competitive markets. And after they have achieved the European Commission's agreement to that, I'm sure that this model will find some reflections in other countries that see themselves faced with the same dilemma. So, the takeaway from this slide, nuclear will grow over the next years, but when you keep in mind that the overall energy demand is predicted to double, this growth rate is not really impressive. So something needs to change. What is that? My suggestion is, let's try to learn from the competition. The economic characteristics of nuclear, we mentioned that a couple of times, is 80% of all the costs, 90% of all the cost is investment. 10% is variable cost. Interestingly enough, the same kind of investment conditions are applicable or are valid for all regenerative energy sources. Definitely for wind, definitely for solar. So what differentiates those technologies from the nuclear technology? Well, they are mass products, generically licensed, and come at a price tag that will not necessarily ruin the investor's financial health should anything go amiss. They also do not require sophisticated technology and know-how to be operated, but can almost be considered a plug-and-play device. Can nuclear do that? I believe yes. What is required is a new nuclear generation device, a sort of next generation of nuclear, that is first of all inherently safe. Meaning, if something goes wrong, the operation stops. There will be no effect to the outside world or to anybody. And ultimately, unless you fix it, nothing will happen. The maximum potential damage of such a device should be the device itself. In order to achieve this, the generation unit needs to be small, which minimizes physical effects like decay heat, but small also should help to create the financing, to facilitate off-site manufacturing, and to reduce operating requirement so that it can almost be remotely controlled. In short, nuclear needs to become small. Ladies and gentlemen, this is not only my conclusion. Increasingly, worldwide, scientists, engineers, politicians, and governments are looking into these possibilities. The request that nuclear should be inherently safe has been reflected in the definition of Generation 4 reactors, the next nuclear generation to be developed. The technologies required are known and have been proven. What needs to be done is to design the concept and demonstrate its features. Now, that sounds quite challenging, but it is not necessarily a unique new nuclear concept. Other industries face similar challenges. And let's give some relief to the automobile industry and take aviation for an example. If you think about the development of a new plane, the industry has an idea, makes a concept, the customers express their interest, then this plane is built, the customers lease it, and some independent financial investors assure that the payment can be returned over the operational time. Now, if you look into an airplane, compared to nuclear technology, it's not less complex. I would even say it's more complex. And if you look into what it costs to develop a new airplane, recent reports on the cost of developing the A350 claim 11 billion euro, you see that that is also quite a challenge. I see no reason why something like this model should not work in nuclear industry. But it would require some governmental support at the beginning, similar, or at least similar in effect, to what the airplane industry is experiencing. Now, first steps in that direction have been done. And I've brought you one example here, which is the new scale design. That is one of the two designs that the US DOE is sponsoring in its development. Now, this design has inherently safety features, but what it mainly does, it is reducing the size to about 50 megawatt per reactor unit. Now, you can, and that's shown in the right part of the, no, sorry, I wanted the pointer. That's shown here in the right part of the graph. You can put up to 12 of these units into one reactor if you necessarily want to go to 600 megawatt. But what it definitely does, it introduces modularity to the reactor building concept. By modularity, you move away from economy of size to economy of number. And I think that is a very important feature. The US DOE does not only sponsor NuScale, they also sponsor mPower, which is a little bigger in its unit size, 80 megawatts if I'm not mistaken, but they also bet on modularity, which means that there are several more units, bigger numbers of units to be built, which ultimately should bring the construction costs down. Now, these two designs are light water reactors. So they use water for neutron moderation and cooling. This technical concept is facilitating the licensing in the US because the US regulator, the US NRC, has hardly any experience in licensing any other concept for civil use. So again, you see that regulation has a big impact on what the developments are in different parts of the country. The energy density of a graphite-moderated, gas-cooled reactor would be even more feasible to inherently safe designs. Due to physics, the energy density of such a design is 10 times less than in case of water cooling. That definitely will facilitate the decay heat control, and it should provide much more chances to have these reactors designed in a way that they can be remotely controlled. The proof of principle that such things work has been initiated by URENCO and partners, the University of Manchester and Delft, which have theoretically developed a design that works like that. We have, with the help of AMEC and Atkins, actually done some basic design work, and what has resulted is this feature here, which we call the uranium battery. Now, this reactor is, again, a magnitude smaller. It only has 4 megawatts, and it's so small that you actually fit it into one of the traditional spent fuel casks, which is shown on the right-hand side of the picture, for transport and ultimate storage. Now, to some of you, that might sound familiar. And yes, you're right. Graphite-moderated and gas-cooled nuclear is a very long-term proven UK technology. If I remember correctly, a reactor of similar design, somewhat bigger, 20 megawatts, was operated in the southwest of England in the 60s, called Dragon. So, as indicated earlier, new simple and small reactors would also ask for a new approach to regulation. But also here, I believe, the UK has a big advantage, because the generic licensing assessment, I think, might allow steps to actually change the licensing process to that what is used in other industry. The licensing should actually be done at the point of manufacturing and not at the site of build. You need a siting permit, I admit that, but in short, why does the licensing of nuclear have to be so much different than the licensing of a wind, a solar, or a diesel generator? Not to be misunderstood, I'm not suggesting here that this innovative approach to nuclear would be able to replace the new nuclear generators that are to be built at Hinkley Point or other UK sites. 16 gigawatts to be built within a decade, or to be installed within a decade, cannot be done on 4 megawatts concepts. This is a development that has to be pushed in parallel as an addition to help to expedite the introduction of nuclear to industrial customers and, more importantly, to small developing nations that have no chance to build big nuclear. Ladies and gentlemen, I do not want to shy away from the question that I raised at the very beginning. What are the economics of all this? I don't believe that these reactors will be able to beat the generation costs of big nuclear. But expecting reasonable numbers to be built, I'm quite confident that they should be able to match the cost of a wind generator, and that should give him a competitive advantage, because with these designs you can determine when you want the electricity and are not depending on weather conditions. And in addition to that, if you look into the UK energy costs, it's obvious that generation costs only form part of the bill. In 2013, 20% of the bill was for distribution and transmission. Now, assuming to be able to build small reactors close to the point where the electricity is needed, these 20% should be earned by your device as well. And keep in mind, please, that in the UK, the 20% we pay is for a well-established distribution and transmission network, which has been serving the country for quite some time. And if you compare that to the cost that you have to invest in countries that don't have this infrastructure, the amount that you have to pay for your that you would have to pay up in your electricity bill allocated to transmission and distribution would be much higher. So ultimately, I believe this should actually also add to the benefit of small nuclear. In summary, Ladies and gentlemen, I first of all have to state that I'm absolutely sure URENCO will not build these reactors. But I can assure you that URENCO will do everything to support these new nuclear developments with its fuel services. As a member of the global nuclear industry, we believe nuclear energy will have to contribute to the future of the growing global demand. And in our view, nuclear is the best suited, best established technology available today to secure power for everybody at affordable cost and with no impact to the environment. URENCO is also a proud member of the UK nuclear industry, which has a unique know-how and an exemplary track record for long-term successful nuclear operations. Given its international renowned licensing system, I believe the UK is well positioned to lead the innovation into a new generation of nuclear power. A nuclear power reactor that can serve the energy needs of all, anywhere on this globe, to provide power in a reliable, affordable, and environmentally secure fashion. Thank you. Yeah, okay.
Well, Helmut, thank you very much for a really interesting talk, and I'm sure that that will have generated some questions from those here. Can I ask you, if you would like to ask a question, that you indicate, raise your hand. The microphone will be passed to you, and then could you give your name and maybe the company that you represent. A question in the front, please.
My name is Bob Alpers. I'm retired.
Bob,
Thank you very much. Could you say something about waste management? Because the two things in people's mind, the public's mind, are inherent safety, and you answer that. But you didn't talk about waste at all. Could you say something about waste management?
Yeah. See, I believe waste is one of the mystery problems of our industry. Waste has been invented as an argument against nuclear by our opponents. It's the nuclear industry that actually is talking it up as a problem. Now let me put waste into perspective. I mentioned 12% of the global power is produced by using nuclear. Now these 12% of nuclear power create about 7,000 tons of spent fuel each year. 7,000 tons of fuel is that what a 1,000 megawatt coal power station needs within one day. 7,000 tons of nuclear spent fuel fit into a basketball field. Now, the real problem we have with nuclear waste is that the volumes are so small that there is no economic solution to actually do something with it. And until we have quantities that really justify doing something, I think we should simply store it, as we do, safely, without any harm to the environment, and then ultimately we keep also the option open to potentially recycle it should that be needed. So in my view, nuclear waste is not a problem today.
okay. Yeah, Dan.
David Marks, you have made no mention of fusion in your address today. Now, fusion has always, well, for the last 50 years, has always been 30 years away. But Lockheed Martin have now come up with the suggestion that they have a solution, a small-scale suggestion of the same order of size as that which you've been proposing. Would you like to say something about the prospects for fusion?
Well, thank you very much for that hint. Let me first stress that I would congratulate Lockheed Martin for their concept, because I believe if they can't build it as small as they promise, it will not fly. And if you look into that, the concept of Lockheed Martin is more or less mirroring or is reflecting what I just tried to introduce to you, that in order to provide future energy needs, you have to get closer to your customer. The other more challenging question in that is, are they really believing that they can develop that in 10 years? Well, the bet's out there. I will monitor it closely.
Okay. A question here? We'll come back.
Biljana Stojkovska, National Grid, UK. So I am part of that 20% that you mentioned, that you can reduce the cost of transmission. And I would like to challenge you on that approach, because nuclear power plants are specific in a way to maintain and operate in the system. So your approach to have all these mini nuclear reactors close to the consumers, I don't think so will improve the operation of the system and improve the security of the system. So that is one of my challenge for you, that transmission will not benefit for this sort of mini nuclear all around. And I also think that British government has been very generous, giving £95 per megawatt hour contracts for difference for nuclear power. And that probably will make nuclear power in the future quite expensive. And you have a serious component on the market, which is offshore wind farms, which would like to come on the market, and we'll see what the future will bring.
Yeah, let me reply to that. I don't know whether you are aware of that the contract of difference you just cited is the least cost contract of difference that has been signed so far by the UK government. The contracts of differences for wind parks and others are all much higher than this one. And ultimately, I can understand your concern for your business. You are right. If my idea flies, your business declines.
We'll take a question there. This gentleman was earlier.
Is this working? Billboard ads, Usable Buildings Trust. You say waste isn't a problem, but before coming this evening, I did a little back-of-the-envelope calculation. And I understand that the cost of nuclear cleanup in Britain, decommissioning a nuclear power stations and Sellafield, is of the order of magnitude of £100 billion. I then calculated the amount of electricity generated since nuclear power stations came online. And if you divide the numbers, you get 4 pence per kilowatt hour, which is about the wholesale price for electricity at the moment. So it looks as if end of life is a really big problem, or has the nuclear industry been talking it up far too much?
I'm not deep into the details, but the cost you are mentioning is not only for the civil use of nuclear power. So in that regard, I'm sorry, I don't have a qualified estimation on which part is for what. But I think the example I've just given, the statistics with 7,000 tons spent fuel and what kind of volume they take, you can actually check on the internet, check everywhere. That is pretty factual.
Okay, yeah. In the front, please.
Hi there. Can you hear me? Yeah. Jonathan Leake, I'm the science editor at Sunday Times. I was just interested in the security implications of having hundreds of small nuclear reactors scattered around the country, and how you might sell that to a minister who might be worried about the use of radioactive fuel by terrorists.
First of all, when you have inherently safe reactors, you should be protected against any outside effects if something goes miss in this machine. On the other hand, if you think about terrorists, first of all, small doesn't mean you can put that in your handbag. Small is still a device that has 120, 160 tonnes that is hard to transport to get there. So actually going there and actually taking it away to misuse it somewhere, I would consider almost impossible. And therefore, I don't see any increase in risk. And on purpose, I mentioned that spent fuel flask, because that spent fuel flask is the device in which today's fuel bundles from industry reactors are stored. If they are considered safe for that purpose, why wouldn't you consider it safe for something that has even less energy than the big reactors?
Hello, Nicola T. Very personal. Have to give a talk next month on nuclear power and why we should support it. So I'm here to grab ideas. My main question, though, comes back to a comment you made fairly early on about decisions being made which you find almost crazy. Having said that, you then mentioned Germany and Angela Merkel, a scientist who appears to have committed her country to non-nuclear power. The risks perceived by the public, who are the ultimate customer, how on earth are you and we going to actually persuade people in the European Union, this country, America, and other developed countries that actually it really is safe?
I think it's a very fair question. But may I apply the same question to an airplane? Yes, absolutely. What persuades you that when you enter an airplane, you're safe to use it? So ultimately, I believe it can only go via experience. And let me come back to my inherently safe design. I know we would have to go through the standard licensing process with it. But what I would prefer to do is to put it on a TV show, say, here, everybody is encouraged to come up with an idea how I can prove that thing is not inherently safe. And then when the spectator quotes go close to zero, you got your license. Yeah? So in that way, I think you have to convince the public, because it's only experience, personal experience, that will help you to convince you that this is safe.
Did you want to come back on that?
Yes, please. As a very confused engineer who's also got a master's degree in social psychology, I totally agree with your comment about flame versus nuclear. The psychologists will tell you that the advantages of flame are so high, obviously. Secondly, and far more importantly, will only kill, even at most, 1,000 people if it comes down. Okay, we'll take the Twin Towers, but the image in people's mind of nuclear goes back to knowing Marie Curie died of radiation poison, Nagasaki, Hiroshima. I simply say them not because I think they are statistically significant, but actually all the evidence shows, and you yourself have actually said the same thing when you compare flame with nuclear. It is not just a problem of the scientists saying this is safe.
See, and maybe I have not brought that over properly, but I absolutely agree with you. It's only if you allow people to experience that they have a benefit from what is happening there that they will accept it. And in that regard, big nuclear has a major problem. It's a big building somewhere, fenced in by Barbary wire, yeah? Now, how is that supposed to be safe? But if you have that thing, right, sitting next to your industry, or sitting next to you, if you have a local community that has regional heating, you might be able to bring that over. But I agree with you, to change the opinion like of the German population will take generations, I'm afraid. Yeah? On the other hand, worldwide, we have people that are starving for energy. People that haven't got the network, that haven't got the grid, yeah? Which would be happy if somebody would put something in there that they simply could switch on and off as they need. And sorry to actually argue against your network again, look what happened to the telephone. 50 years ago, every country had a distribution of landlines. If you go into developing countries today, nobody has a landline. They all work on mobile phones. Yeah? And so things will change always. But you have, and there I'm absolutely with you, you have to show the customer. The customer is ultimately the individual, Joe Block. You have to convince him that that is to his advantage, that is to his benefit. And that's why the example from the car, I thought, was not so far-fetched.
Okay, just to tell you, the network business is not a private business anyway. If you want to operate the system and you want to have electricity, you will need to have a network which will help
Distribution,
you. Which should help you when your mini reactor is not working. So you will be dependent on somebody else. That is the network. The business-wise, it's okay. I agree with you. But there is other aspects of security, supply, which you mentioned.
I think you were exaggerating slightly, but I know the two gentlemen here have been trying to ask a question. Shall we? Don't mind which order you go in.
Is this working?
Yes.
Do you see any future for a different kind of design compared with the present kind of nuclear power stations that we have, based on something along the lines of the liquid fuel kind of reactor, and also as far as reducing the amount of waste that may well be a problem, to make use of thorium as the base of the fuel?
Ultimately, I believe economics will dictate that. And I believe that our industry is at a very crucial point, because if we do not find solutions that actually fit the developing world and the competitive energy markets, I'm afraid nuclear will be constrained to China and India, and the Western society will lose its know-how to that regard. If you can get a new role for nuclear by making it smaller, by sizing it better to the customer's needs, I think all the developments you just triggered or you just mentioned will happen by itself. But I think the key point is that nuclear has to move from a bespoke design to a mass product. Otherwise, I see economic difficulties for the future.
Okay. And the gentleman next to you.
Thank you, Dr. Engelberg. My name is Ghosh. I'm from AT Consultancy. Your lecture is very interesting, in particular for poor countries, because we can now have nuclear power station in a small unit. Now, in your opinion, what can be the smallest practical unit? And number two, what is the likely to be unit cost measured per unit megawatt generation and such? And third part is that what are the fuel choice one can have? Because uranium, of course, is a restricted product, and one needs to be quite got a license for that. And in India, they have been working on thorium for a while, and I don't know if you can throw some more light on that one. Thank you.
Yeah.
Perhaps too long, but I'll give you a chance to answer that first.
Well, the economic question is very much depending on how many units you will be building. That's key to everything. I think what we challenged the universities to is to actually come up with the smallest design they could find, and that was this 4 megawatt. Much smaller you can't do it, because then the geometry is just too small. But interesting, as you mention it, thorium would be used for this thing, because it is a way to avoid the initial poisoning of the reactor, but use rather thorium to catch the excess neutrons, and later on use the 232 as a fuel. This will allow the recharging times that I mentioned, 5 to 10 years, to happen.
Okay, thank you. Steve?
So, as you probably know, the UK is looking at what we should do with small modular reactors at this point. There was a study by Gordon Waddington last year of Rolls-Royce for DEC that looked at these options. There's a bewildering set of options. And one of the things we don't want to do in the UK nuclear industry at this point is repeat some of our past excesses of choice. You're giving us one choice with the U battery, and the US has 3 choices, I think, and China has 1, and there's a question in this country as to whether we should just have a UK SMR completely designed and built in this country and capture all the IP from that. Do you have an opinion in this race, or is it, have you already given it?
Well, I have an opinion, certainly. I believe the UK has a very unique know-how in graphite moderated and gas cooled. And I have tried to explain that the SMRs that are developed today are all light water reactors, but simply to physics, they cannot get that small. But if the UK wants really to take the lead in a development, I think they should bank on their historic know-how. Trying to catch up with somebody is much harder than using what you have and actually developing it. And I think that is the challenge that the UK will have to answer, whether they want to go in the lead or whether they just want to do what everybody else does as well.
But there's not much point going in the lead unless you're able to sell it to others and others follow you.
Yeah.
Do you think that would be a market that would be attractive elsewhere or not?
Well, as I indicated, I believe the key market would be the developing nations, which also would mean that you have to change the service around it. You would have to provide it and take it back as it comes. If you look into the possibilities around that and the need for that, the market is big. But it needs the courage, it needs the commitment to actually see that through. And I believe the UK has everything needed to actually go that way, but it needs leadership, it needs the initiative to bring this about. And yeah, I would love to do it myself, but it is unfortunately not the skill set of my company, and it certainly would not find the support of our board, I'm sure. But I think it would be the right way to do it.
You're suggesting that we don't make partnerships with the Americans on the two DOE designs, which have already had hundreds of millions spent on them, because you think the gas-cooled reactor is so much of a better option.
Well, if this is a choice to be made, you can buy these 100 megawatt, these new scale or M-power reactors at some point in time. I'm pretty sure.
But we could also join them and be jointly producing them. So that offer is on the table.
Okay, then I was not aware of that, but if that's a choice, that's something for the UK to decide. Yeah? If you want to make use of your specific know-how, my recommendation is you look at what you're best at and try to develop from there.
A question here?
David Morris. I just wonder what you think of the current program in the UK in nuclear scale. The next one is planned to be at Hinkley Point in Somerset. I think you mentioned that, and another one in Sizewell, and no doubt another one. And these will be in a much bigger, much more usual series we've seen heretofore. Do you feel that that sort of program, which in the case of Hinkley Point embodies both Chinese and French involvement, particularly technical, no doubt, and financial as well, of course. Are we on the right course for those?
Well, I believe over the last 60 years, nuclear has served this country well. You had a reliable fleet of nuclear generation, which you unfortunately have now used to the end of its life expectancy. And you have an urgent, UK has an urgent replacement demand. Now, honestly, what the government has done here with the contract of difference is actually matching the controversial matters of long-term infrastructure investment and competitive markets. And I think they're doing the right thing to giving that to different providers, because it is all not your original UK know-how, and they cannot be sure that that design is better than that, so you're testing it. When you're concerned about foreign investors, I wouldn't share that necessarily. These reactors will be built in Hinkley Point, and the Chinese owner, should there ever be in China, will not take it away. Yeah? if you're concerned about transfer of intellectual property, you should rather look into the brains and the intellectual know-how than into the infrastructure. So I wouldn't have any concern with foreign investment in infrastructure.
So give us a green light.
Sorry?
Give us a green light.
not for me to do. You wait for your next government. I'm unfortunately not allowed to do that.
Oh, lots of hands. So in the back row.
Hello. Hello. Hi, David Martin from the Alvin Weinberg Foundation. I'd just like to ask a couple of questions, if I may. First, the Dragon reactor at Winfrith was operated safely up to about 1600 degrees centigrade. So do you see this U battery, the successor really to Dragon, as making inroads into the global process heat market, which is a major source of carbon emissions? And the second, the UK budget for reactor R&D has been cut by about 99% in the last 25 years. What do you think the UK government should do today to accelerate the research and development of advanced reactors in the UK? Thanks.
Well, the first one is the easier one. Yes, as this is also referred to as a high-temperature reactor, you definitely would be able to provide process heating. But coming to the political question and the minefield you've set there for me, I think the UK, as I indicated, has a long, valuable tradition and know-how in nuclear. And ultimately, countries have to make the decisions on which industry they want to excel in. So this is an infrastructure, is an investment policy choice for your governments to make. I personally, being a fan of nuclear, being a fan of these designs, would recommend the UK government to go for that. But ultimately, it's all your choice. You have to vote for these governments.
Thank you. And next.
Oh, hello. My name is Kirsty Gogan from Energy for Humanity. Thank you so much for your lecture. I thought it was wonderful, and I very much supported your position, especially with regards to the need for nuclear to meet the challenges of air pollution and climate change and rising global energy demand. With that in mind, my question really is about what you would recommend as, you know, the key actions that should be taken to accelerate nuclear power globally, the deployment and development of nuclear power globally, with regards to, for example, you mentioned international licensing or changes to the institutional landscape. This is something that is an issue that's really close to our hearts, because currently we see the major barriers as being around the issues that we've heard tonight, which are safety, cost, waste, proliferation. And wrapped around that is the question of public perception. So I would be grateful if you could answer that question. And I'm sorry to take up much time, but I just wanted to respond to the comment earlier about Sellafield and the costs of decommissioning, just to say that I have a little bit of insight onto this issue, and 80% of the legacy waste decommissioning costs in this country are related to military, and in particular to the development of the Cold War deterrent. So it's a military legacy, much more than a civil nuclear legacy. Thank you.
Do you have a reference for that? Sorry.
Yeah, if you look on the World Nuclear Association, the WNA, World Nuclear Association website, you'll see there some really good, up-to-date analysis on the costs of decommissioning, which essentially are a margin of error. Thank you.
Well, as indicated a couple of times, and I'm repeating myself here now, our industry will have to change. Change is normal. And when you actually think of advocating small nuclear for developing countries, you have to see that that has to be done in a different way. It is more or less like the Russians are now providing nuclear power to Turkey. They build, they operate, and they decommission this facility, and the only thing that the Turkish are doing is paying the electricity bill. Now, this is the model that you will have to apply also to developing countries. And in particular, when you go and invest in small reactors in these countries, I think that needs to be the solution. I know that that needs some legislation changes, that needs some international debate, because it will require the country that produces these reactors more or less to take the reactor back, including the spent fuel, which is not very much appreciated these days. But quite honestly, if you see that France, for instance, is exporting 40% of its nuclear-generated electricity, where is the difference? For 40% of their nuclear energy exported, they keep the fuel, which in the other case would be with the country that has consumed the electricity. So I think with some education, with some debate, that could be done. And on the other hand, you have to see that the developing countries will want to have our standard of living. And if we don't give them nuclear, they will burn their woods. You would do that as well. Your survival is the most necessary requirement. So by providing technology, you actually live up. If you have the technology, you also create a responsibility with it, because you create the responsibility to provide that solution to others so that they can benefit from it without using it to their harm. And this is same is true to nuclear. If you have such a solution, provide it, educate them, give them the know-how, but give them first of all the possibility to use it. And that, I think, is what will help to accelerate the global understanding for environment protection and sustainable use of resources.
Thank you. A question here?
Yes, Scott Steedman. Helmut, thank you for an excellent lecture and discussion. We've talked a lot about the engineering, the technology, the economic model, the safety, and you teased us earlier on, generously saying the UK had a skills base, and we haven't really talked about that aspect. I'd be very interested in your comments on the need for training and professional development of engineers to service this brave new world of technology and exporting of SMRs and returning them to the UK and future models and so on. You need quite a substantial throughput of young engineers wanting to take up such a profession, and they need to be professionally qualified, trained, and so on. Do you have any comment on the professional side?
Well, we work in an international environment as URENCO, as you know, in 4 countries. And interesting enough, we have never found difficulties to attract the right skill set to our industry. That said, I strongly believe that engineering scientific education is a necessity and should start as early as possible. You might have seen that URENCO is heavily engaged in actually introducing to children the interest in scientific features and in basic science recognition. Because I've learned that from some other companies who, in their desire to find future engineers, actually started to approach the in kindergarten to find their interest. And I believe that's very true, because at the point in time when everybody else is studying law and you haven't formed your interest for science, you will go for law as well, whether you should have rather done something else or not. So I think it is a long-term program that you have to actually roll out here, that should start with basic education to create the interest of everybody in science. And then we should simply accept that not everybody has the same skill set, and we shouldn't be absolutely frustrated if then somebody nevertheless turns to law. But ultimately, I hope in that manner we could find much more interest in science and engineering than we see today.
Yeah, well, I think we'll all agree with that one, and it really does mean doing it collaboratively and not confusing the young.
Yeah.
So, with a question here.
Mark Whitby, I've really enjoyed this talk, especially the concept of the nuclear battery and the brave new world. And I'm very much an engineer in that sense. But today, over the breakfast table, my young son was asking me a few questions. And as a result, I went and bought The Economist. So my first question is, have you read this week's Economist? And what do you think of the supplement in there on energy? I haven't read it all myself yet. It's a bit fresh in bag. But what was most interesting was the projections and that you've been making, and the fact that the GDP, the energy consumption per GDP is falling quite dramatically in the developed world, and that we've been seeing in this country a 1% per annum reduction in energy consumption. And this might be linked to the recession, but it's not looking like it necessarily is linked. And my sense is that, as is borne out by other articles in the Economist, that we are becoming much more economic in our use of energy and much more sensitive about it, not just from the point of view of cost, although costs are going up, but from the point of view of a social sense of our role in society. And really, I'm not convinced at all that the world's energy consumption is set to double.
Well, like with all predictions, future will show. But I believe it honestly doesn't matter, because if you see the needs for electricity, and electricity is ultimately the form of energy that allows you to have the best way of using it, I think there is no doubt that the demand is growing bigger. Whether it will double or only go up 80 or 50% doesn't really matter. We need new solutions for energy, and in particular, if you look into the need for providing fresh water everywhere, I think it becomes obvious that there is increasing demand. But future will show.
Back slightly on that. Anybody who wants to really see how the British or the French use their energy needs to go and visit a website called Gridwatch. And on that you can see just how much the French export, just exactly where it comes from, and what proportions, particularly in England, are being generated. It happens very instant. Because it's a totally applied. Backdates the whole year, so you can do it from that point of view at all. It's very informative, and you can actually see some interesting trends that are resulting from, let's say, falling price of oil and gas.
A question over here?
Certainly. David Hess, World Nuclear Association. First of all, I would like to thank you for what I think was one of the best presented and most consistent visions for SMRs that I've yet seen. And just drawing on sort of one aspect of that, which is flexibility, which is something, having looked at SMRs, I think has to be one of the key characteristics that you're looking at sort of achieving in order for these to be a successful product. And you talked about their possible application in developing world countries, or probably developing economies is a better word, I guess. But another sort of use for these has always been pictured as kind of slotting into existing grids, but in places where the demand is perhaps a bit more flat, perhaps to replace smaller fossil units. I guess the problem is that the economics doesn't seem to really suit this. So if you consider that the direct sort of fossil competition for a large nuclear generation is coal, and if you're replacing one baseload plant, it makes sense to use another baseload plant to kind of replace it. For SMRs, a sort of natural competitor would be gas. But the gas plant economics, they manage to sort of, they turn off when the price is low and then generate again when the price is high. Can an SMR concept like yours, or like any other ones, can they effectively tap into that gas market economics in order to be viable, do you think? Oh, it's just to finish, because when you look at the future mix, it's almost certain that the amount of renewables will increase. And this will sort of increase the demand for more flexible generation options.
Well, let me give you one of my favorite cases, which is not a direct answer to your question, which I appreciate. What do you consider nuclear? Renewable or not?
Well, I've got an answer to that.
What do you consider geothermal? Most people consider it renewable. Well, nuclear is nothing but geothermal brought upstairs. So, in that regard, nuclear is renewable as well. Going to your competition question with gas, I think it depends very much where you are. And it depends very much how the markets are. And I tried to explain that. Ultimately, electricity supply is a base need for human society. Now, do you really want to bet on just one horse? If you would ask me, do you want to have everything in nuclear, I would hesitate, because that would be the mistake to the other side. But as I mentioned, some of our US customers in the regulated environment say, I cannot possibly stand up in front of my customer and say, I have built everything of your electricity supply in gas and now I'm out of gas. So they want to have a different source. And therefore, I think there will always be a mix, there will always be a diversity of supply sources, and we have just to ensure that these technologies are used in the right mix with each other so that they actually facilitate their strengths and weaknesses and help to overcome each other's strengths and weaknesses. And then I think you have the foundation for a secure supply of energy, because ultimately affordability and environmental impact are secondary targets. If you don't have the supply of energy, you will do everything to get it.
Thank you. Well, Helmut, we've run out of time. I see hands waving around the room. You've given us a really interesting and stimulating lecture, and presented a very coherent picture and image of the future for SMRs. And you can see that you've generated lots of interest in the audience, lots of questions, and I think we could easily spend another hour here. But I know many people are keen to get off and have a drink, and the reception is due to start right now, and I really do feel I have to draw this to a close. But thank you very much. It's been a great evening, and we're very grateful to you for your really interesting lecture.